All right, everybody, we thank you for your patience. We're going to go ahead and get started. I'm going to do brief introductions. Have a pretty good session planned for you all today. First presenter is going to be Ron Knezevich. Ron Knezevich currently works as the State Pedestrian and Bicycle Engineer at the Georgia Department of Transportation. He has a master's degree and bachelor's degree in civil engineering from Georgia Tech. And in his master's degree, he completed a thesis on data science and traffic safety. His goal is to utilize emerging technologies and analytic techniques to cut down roadway fatalities. Our group of second presenters, first is going to be Chris Rideout. Chris Rideout has more than 30 years of transportation engineering experience that includes all aspects of roadway design. His expertise includes horizontal and vertical alignment layout, cross-section development, drainage design, signing and marking, traffic signal design, staging detour plans, quantity takeoffs, cost estimating using the cost estimating system, and the review and certification of erosion control plans to satisfy the current National Pollutant Discharge System and best management practice requirements. Rideout also has experience in concept report development and validation, VE study implementation, preparation of design exceptions and variances, as well as assisting with the environmental process, including preparing stream buffer variance applications. He is well versed in the QA/QC process, as well as preparing for and participating in constructability reviews for design plans. Rideout is a member of the American Society of Civil Engineers and the American Society of Highway Engineers. Presenting with him is Eric Brisse. Brisse has more than 12 years of experience as a design engineer and project manager. During his more than a decade with Croy's transportation team, his responsibilities have included conceptual design and report preparation, horizontal and vertical alignment design, drainage design, cross-section generation. Skip the rest? All right. We're going to skip the request on his request. We'll skip the rest, and we'll move on to Ron's presentation. And we're going to hold all questions to the end if we have to.
All right. Hey, everyone. I'm Ron. How's the volume? Can you hear me okay? How about the people online? Hopefully, thumbs up, maybe. Maybe not. All right. So I'm Ron. I'm the State Pedestrian and Bicycle Engineer at the Georgia Department of Transportation. As Raul said, a lot of my background's in data science and data analytics. What that means is I like to build prediction models, and I like to automate things. A lot of civil engineering decisions can't be fully automated. I'm hoping to show you today we can get pretty close to making a good decision. So I'm speaking on a data-driven pedestrian safety analysis at bus stops today. I have 3 takeaways for you guys. One is pedestrian crashes are inherently random events, but those pedestrian fatalities are an increasing concern. 2 is proactive measures can be used to help justify systemic or network level safety projects. And 3, identifying project focus and the countermeasures you want to implement before conducting a network screening or system-wide approach can help expedite the safety process study. So first I'll be going through some background. If you've seen some of my presentations in the past, you'll see some reused slides in this background on pedestrian safety, proactive safety, bus stop safety, as well as the safety management process. Then I'll be going through the study conducted on a pedestrian safety analysis for MARTA bus stops. Though this analysis was done with MARTA bus stops, we're hoping to do more with any bus stop network. So send me your data, you'll get a pretty good study coming out. All right, so first into that background. Over the last 15 years, we have been seeing an increasing proportion of our pedestrian fatalities. Back in 2006, less than 10% of our roadway fatalities involved a pedestrian. That number is closer to 20% today. So if you've been in this industry for about 15 years or longer, pedestrian safety is more of a concern today than it was back then. Proactive safety. This term people kind of get flustered by a bit, but all it means is anticipating fatalities before they happen rather than reacting after, not dealing with just crash data alone. You might be saying, what is this World War II playing here? So I once got a citizen request. And as citizens do, they love to elaborate on long stories to me over their phone calls. So what he said was, Ron, we need a bike lane on this road here. I can't bike to work. I said, okay, I'll go take a look at the crash data, see what I can do. He tells me, well, son, you really should be looking at more than just crash data. Back in World War II, I don't think he was alive back then, but says back in World War II, planes used to come back from battle with Germany with bullet holes in the wings and the center of the plane. It became obvious what needed to be done to reinforce that plane, strengthen the wings, and strengthen the center. But as it turned out, that was a fatal flaw. The cockpit and the engines were actually the most vulnerable part of that plane, but when they were shot there, they just never returned home. So crash data, it's not bullet holes in the plane. There's a lot of holes in that metaphor there, but it's an illustration that we should be using more than just crash data to justify our safety improvements. And the reason for that, especially for those pedestrian and bicycle crashes, is I get an intersection like this all the time. It comes up. You have a lot of vehicular crashes at that intersection. We have a lot of vehicular crash data that the safety program has stored up for years, a very robust database. But what you'll see here is tons of vehicle crashes, one pedestrian crash, and that one pedestrian crash is a fatality. We don't have the best pedestrian crash database. These things are often underreported and not reported. Sometimes people just walk them off. Pedestrian crashes make up less than 1% of all of our crash data, but almost 20% of our fatalities. So if you're only assessing crash data when making a pedestrian safety decision, you're doing it wrong. Moving to systemic analysis, that often gets used interchangeably with proactive safety, but is not the same. Systemic safety is a way to manage risk across the system. It actually comes from the medical industry. So what you're seeing here is a slide from one of the classes I helped develop at Georgia Tech on systemic safety. So medical practices or systemic risk is something like diabetes or Alzheimer's, things that affect the body as a whole, rather than an isolated cough or cold targeting a specific organ. Systemic risk is diagnosed by assessing not just your symptoms or the crash data, but also diagnosing those underlying conditions, your family history, things such as that, or underlying risk factors you as a person may have. This is the same thing with roadway safety. We should not be just assessing the crash data on the roads, but also a variety of other factors such as lane number, traffic volume, intersection skew, etc. Now onto bus stop safety. Why this study is focused on bus stops. In the Highway Safety Manual, it's identified as a risk factor. If you're familiar with crash modification factors, there's a CMF for bus stops in the Highway Safety Manual. This is because bus stops are locations where people tend to cross the road, whether it's at an intersection or not. So we're trying to make them safer in general. Moving on to the highway safety management process. If you're a safety engineer, you should be familiar with this table. It's from the Highway Safety Manual. Our process works by conducting a network screening, finding those locations to implement safety projects, then diagnosing what that safety concern is selecting a countermeasure, conducting an economic analysis, project prioritization, and then evaluating how you did. Today, I'll be going through morphing all those circled in red into that network screening level. So preliminary network screening that conducts the diagnosis, countermeasures, economic analysis, and project prioritization. Very preliminary versions of all of those, but gives us a good starting point. All right, now moving on to the study on pedestrian safety at MARTA bus stops. And as I said earlier, this study, hopefully we can move on to other types of bus stop networks. So first, establishing focus. When conducting a network screening, you want to isolate a crash type, a certain type of safety concern. Here we're doing bus stops, pedestrian crashes, or pedestrian safety in general, and mid-block or unsignalized intersections. Though signalized intersections, we could have a whole project there as well, but that's a completely different type of countermeasure that you would implement than mid-block crossing. So you really want two different types of projects, because what you're going to do to a signalized intersection is not the same that you would do to a mid-block. All right, now into the data sets. So for our MARTA bus stop data, what I used was the location as well as the ridership, or vehicles per day, or passengers per day. The roadway inventory, GDOT has a robust data set of all of our roadway networks with lane number, traffic volume, speed limit, as well as the presence of a median or divided roadway. And the signal inventory, just so I could get rid of those bus stops that were out of signal, the locations. And social vulnerability, or CDC's SVI, Social Vulnerability Index. If you've seen one of my presentations before, I bring this one up all the time. The CDC social vulnerability is an indicator of vulnerability of that population. It takes into account a variety of different demographic data, such as age, income level, race, and what was used particularly in this study is housing type and transportation. What this is access to transportation of those roadway users. This one was particularly influential in the model discussed today because if you have lack of access to good transportation, you're probably using those MARTA bus stops or you're walking around. So this becomes a risk factor even more at these bus stops. Now, how do we quantify that proactive safety? As a safety engineer, we want to quantify all of our decisions. We need a dollar value associated to everything. So that's where crash prediction comes in. So I said earlier, I'm a data scientist. I love building prediction models. I'll build prediction models for all the regions here in the state. This is a pedestrian safety performance function is what the term is typically used as. And it's essentially an equation that combines a variety of risk factors and demographic data to predict pedestrian crashes. The risk factors we're seeing here are ridership, those vehicles per day, the presence of an intersection. GDOT actually has a robust data set now, very recently developed on our platform Numetric, of the locations of all of our intersections in the state. It's not perfect. It's Savannah, actually, a lot of those intersections are fairly close together, and it's data challenge to separate out an intersection when they're only a couple of feet apart. Lane number, more lanes, more crashes. Traffic volume, higher traffic volume roadways, we're predicting more crashes. That social vulnerability, those more vulnerable populations are the locations where we have more pedestrian crashes. And roadway division, undivided roadways have more pedestrian crashes or lack of a median. All those variables are not influencing that equation or the model the same way. Ridership is the most influential variable, as is a measure of exposure of how many pedestrians are actually walking by that bus stop per day. Then the presence of an intersection, more people are tending to cross at those intersections. Lane number, then followed by traffic volume, that's social vulnerability, and then roadway division. So what I went through was an equation on predicting crashes. I have an actual formula for that equation. It's a little too technical for this presentation today, though. But aside from predicting crashes, we want to predict crash severity too, which is a very different thing. GDOT has these various crash costs for all of our different severity levels of crashes. These have been updated for adjustments in inflation, so you might be using older crash costs. Just like our construction costs have gone up in the last couple of years, so have our crash costs. So if you've ever wondered what the value of a human life is in traffic engineering, about $12.5 million. So this is how we quantify where to put different safety projects. So on our various roadways, though, higher speed roadways have more severe pedestrian crashes. We're not seeing more pedestrian crashes on our higher speed roadways, but those crashes that happen are much more severe. So what this table here is, you'll see the higher the speed roadway, the higher that dollar value is for those pedestrian crashes. And this is derived from our own data. See, on 45 mile per hour roadways, we have a dollar value of about 3 million, while under 25 mile per hour roadways, those pedestrian crashes are only worth about 600,000. So we just predicted crashes, we predicted severity. Moving on to, well, combining that data with our observed crash history. Highway safety engineers use a term called expected crash frequency. There's a lot of methods in the highway safety manual on how to calculate that. But what we're recommending to do at this point in time is weigh those 50% predicted crashes from those risk-based model, as well as 50% just from what's actually going on the roadway. What are those pedestrian crashes actually there? So you can gauge both proactively and reactively. So we're not just ignoring locations where crashes are happening. Same thing with crash costs as well, predicting both crashes and crash cost. That was my prediction model. Now moving on to the treatment selection. 3 types of countermeasures were used in the study to be implemented on this network level: pedestrian hybrid beacons, rectangular rapid flashing beacons or RFBs, and a raised crosswalk. Pedestrian hybrid beacons have a crash reduction for pedestrians of about 55%, but they also reduce vehicle crashes too. And their cost is approximately around $60,000. That number is a little higher for including professional engineering as well. Rectangular rapid flashing beacons, they reduce crashes a little bit less, but they're a cheaper countermeasure. And they also have a very high percent reduction in yielding rates, or increase in yielding rates, about 98% increase in the amount of vehicles that yield to pedestrians at crosswalks. And then we have a raised crosswalk, cheaper countermeasure in most scenarios, 45% reduction in pedestrian crashes. But what's different about this is it's not applicable on all your types of roadways. These 3 countermeasures are not always applicable. We have guidance from FHWA, guidance from GDOT in our pedestrian streetscape guide on where we should be putting these type of countermeasures. We also have guidance from the MUTCD. Yes, I say guidance from the MUTCD, not warrants. That is the biggest comment I give in my traffic engineering study. There is no PHB warrant, it is PHB guidance. And what is often referenced is only the volume warrants, the vehicle volume versus pedestrian volume. It is not a warrant, first of all, it's guidance. And there's also another section of that guidance on safety, just as important as those volumes. You should be considering safety for what type of crossing you're recommending, not just volumes when programming PHBs or RFBs. What it says in the MUTCD is consider gaps for those pedestrians, the speed of the roadway, the crossing distance, etc. And that goes back to our table in the pedestrian streetscape guide and our guidance provided there. So using all of that guidance, I formulated this table here just for the purposes of this study. So the tables in our guidance are a little bit more flexible. This one gives a conservative decision on what the best type of countermeasure should be. So you see, as lane number goes up, as traffic volume goes up, and as speed goes up, we're implementing a more expensive countermeasure that's going to reduce crashes more effectively. Those pedestrian hybrid beacons are just going to be the most visible on a higher speed roadway. You can see a raised crosswalk is only applicable on those low volume, low speed, low lane number roadways. All right, so now we've decided what type of countermeasures we're implementing. Economic analysis, or our benefit cost ratio, is how we do economic analysis in the safety program at GDOT. If you're a roadway designer in this meeting and you don't know what a benefit cost ratio is for safety, if you're working on a safety project, this should be calculated. If we go below a BC of 1 or often below a BC of 2, we lose funding for that project. So you need to be recalculating that benefit cost ratio if you're changing project costs, because that will end the project entirely if you make it too expensive, which happens quite often. And that is the safety benefit over the life cycle cost of a project, which is the monetary reduction in crashes per year. Those crash costs I gave multiplied by the crash reduction factor over the cost of that treatment over its life cycle. So not just the cost, but some treatments last for 20 years, some treatments last for 10 years. I can provide equations for this. They're actually in slides at the end later, but there's more formulas to how to calculate that BC ratio. All right, now to some of the good stuff. The bus stop study actually conducted. So as I said, we started with all the bus stops, or all the MARTA bus stops, removed all the signalized, the bus stops at signals, still working on getting a better signalized database. I noticed we were missing some. And then recommending that countermeasure at all of them. So this is not where we're actually proposing a project. This is what was recommended from that table I proposed. So what you'll see is on those higher speed, higher volume roadways, we're seeing PHBs, we're seeing RFBs on those minor arterials, and raised crosswalks on those side streets. We can rank those by the benefit cost ratio to try and narrow our scope, and we can filter to just ones where we have a very high benefit cost ratio. Because in the safety program, we have to be prioritizing our funding just in those locations where we get that highest benefit cost ratio. And to show an example of, we're not using a observed benefit cost ratio, we're calculating this expected benefit cost ratio, which is a proactive ratio. I see two intersections here. Don't get too hung up on the locations of these two crossings. These are just two bus stops, but they're about 400 feet apart. And what you're seeing is one with, if we were to use our historical benefit cost ratio with only the crash data, we have a 0. But once we use that predictive approach and the proactive measures, we now have an economically feasible project of around 7. In the other crossing, we see an observed benefit cost ratio of 22, meaning there was some crash data here. Then pedestrian hybrid beacon was justified, but it lowered a bit to about 14 or 15, as you're seeing there. So what that proactive approach is doing, and that systemic approach, kind of spreading out that benefit cost ratio, not just at locations where the crashes are happening, but where they could happen. We're not trying to prevent crashes that already happened. We're trying to prevent crashes that will happen in the future. Crashes that happened. We're trying to prevent ones that could happen. And that location right next to it with all the same risk factors is nearly as likely to have a crash in the future. So I went through that whole approach. There's a lot more to consider. We're still working on narrowing down what projects we're actually going to implement. There's things like, how do we group these projects by area office? We want to avoid curvatures of grade. We want to combine projects based on proximity. Consider right-of-way. Do some projects where we don't have to purchase right-of-way, because that can be a lot quicker process. Some projects where we do have to purchase right-of-way. Want to move some of the bus stops, and of course we'll want to talk and coordinate with MARTA on this project, as well as any other transit authority. So again, my 3 takeaways: pedestrian crashes, they are inherently random events, but nevertheless those fatalities are an increasing concern. Proactive approaches, as shown today, can be used to help justify a systemic safety project, and identifying that project focus and potential countermeasures before a network screening can help expedite that process and make a quicker selection of those countermeasures from the get-go. So thank you very much. I'm Ron Knezevich. Please email me if you have any questions. I have lots of extra technical slides if you want to follow up on that later, but they're at the end here. Thank you very much.
All right, appreciate everybody hanging out with us tonight. I know Eric and I are in between dinner and a few cocktails here in a bit, so we'll try, and we're running late, so we'll try to go as quick as we can. As mentioned, my name is Chris Rideout. This is Eric Brisse. We're with Croy Engineering. We're going to talk about the Windy Hill project today. Real fast, always got to talk about Croy for a second. About 120 people. Based out of Marietta, Georgia. We also have offices in Chattanooga and Huntsville, Alabama. Been around for about 18 years, so good while now. We do everything. We do transportation, we do traffic, we do survey, we do land acquisition, we do aviation, so we do a little bit of everything. So like I say, I'm going quick here because I know we're running behind, but that's a little snapshot of Croy Engineering. There's our great headshots, gotta love that. Yeah, this whole thing's made me feel really old today between earlier today and my bio of 30 years. Apparently I'm a Gen X, but I'm really feeling like a boomer, but oh, sorry. So yeah, it's but so we're going to talk about Windy Hill today, and we're going to talk about connectivity. We're going to talk about constructability, cost, and utilities. And it's all going to come back to this is a major project through Smyrna. But the goal is get the vehicles through while keeping the pedestrians, bicyclists, and getting them more connected than they ever have been. Windy Hill has many names. It's been around for a very long time. And it's a 5-lane urban roadway and the stretch we're talking about is between South Cobb and Atlanta Road. Super heavy traffic volumes that, we've got challenges. It basically splits. It's almost part of North Smyrna. It's almost like being on the other side of the tracks. There's a lot of issues out there from the pedestrians. To the north is a lot of residential. To the south, we have elementary schools and high schools. So there's a lot of pedestrian movement out there. They don't pay attention to signals. They cross anywhere they want. It's a 5-lane section with a center turn lane. And so it's a really challenging site. The city really wanted to do something to improve it. Overall, it's the big picture. Windy Hill basically goes from Ostell Road to I-75. It's a long corridor. It's a little over 5 miles long. And so trying to improve the whole thing is hard to do funding wise. So the city kind of looked at, and sorry, forgot this little piece. We're also working to connect all the trails in the area from the Mountain to River Trail. There's Village Parkway Trail. All that connects to the Silver Comet Trail to the south. So this project will help improve all of that. Like I mentioned, the original project was a very large scale project, multi-phase. We originally went after some funding from the state. It's not a state route. So that kind of, was a no-go. So eventually the city of Smyrna stepped up. They funded pretty much half the project with Cobb County funding the other half through the Cobb County SPLOST program. Here's the original corridor that's been looked at, like I say, from I-75 all the way to Ostell Road. And then this is our section right here. Basically, it's from South Cobb Drive to Atlanta Road. I'm not going to bore you with the overall timeline. One thing I wanted to point out here is the project's been going on for a while. Basically, back in 2007, our founder, Mr. Croy, sat down with one of the commissioners, Bob Ott, back of a napkin and said, hey, we know there's projects coming. They're going to make Windy Hill even more congested. What can we do? One of those big projects was the Windy Mac project that if you're familiar with West Cobb, you're very familiar with this project. It was starting construction in 2009, opened, I think, in 2011 or 12. And it basically took all of Paulding County, West Cobb, put them on Windy Hill Road, and totally, it made what was already bad congestion, made it twice as much. I think the number, the design year we're dealing with is 37,000 is ADT as our design year. And so, like I said, it started in 2007. Here in 2023, we're halfway through construction. We'll get to see a little bit of that in a minute. So what was our goal here? Our goal here is to move the vehicles through Smyrna efficiently while maintaining and adding to our pedestrian and our bicycle, family, so to speak. And so, the citizens, they want, bike lanes, they want wide sidewalks and, areas for BRT and whatnot. Challenge we have with that is to get all that in, you're really slowing down the traffic with your crosswalks, the long pedestrian crossings, large, the signalized timing and that kind of stuff. So really tried to come up with a mix that will solve both of those issues, or all of those issues, excuse me. So we kind of come up, we kind of started thinking out of the box. And what you see here is a roundabout sitting on top of a express lanes in Barcelona, Spain. So that was kind of our initial inspiration for this project. And it's not something you would normally see. We're starting to see more of them in the region and the nation. And so this was something we kind of came up with. That's one of our first concepts that we had in the project. And like I say, the goal is to move the traffic while also keeping the pedestrians and bicyclists happy, connected between the north and south of Windy Hill Road. This is another picture of that same roadway. You can see the bridge structures going over the express lanes, one lane roads in each direction. This is one of our original SketchUps, is what you can see of what we visualized Windy Hill, even with some development on the south side. This is another one where if you zoom in, this is almost identical to what we're going to end up with when our project is complete. We have one-way traffic with turnarounds and with the express lanes going underneath. So once again, we're trying to keep those pedestrians in mind at every step of the way in this project. Once again, there's our concept. This is this is where we started getting into some renderings. At this point, we've got the ideas, and then we're trying to figure out how to really express those ideas. We had some challenges on this project. We've got, it's a 5-lane section, heavy commercial. So where do you put the road? Turns out we also have a post office on the south side. We know what it's like to touch a federal building, so that was a no-go. We also have transmission lines along the south side, and we know how expensive those are to move. So going to the south was not an option. There's also a barbecue joint that we were told no, do not touch. So it made the whole decision to go north easy. When I say easy, it wasn't easy, but that was an obvious decision. So you can see here, this is one of our original concepts where we show everything shifting to the north. One of the advantages of what we've come up with is we've got 2 lanes, 1 lane each direction for the local access. And then we allow them for numerous locations to do turnarounds. So no matter where you are, once you get on the local access in either direction, you have an opportunity to get anywhere you want along this corridor. You just got to go up and do some we got 2 bridges kind of they're almost like roundabouts, perfect U-turn movements, and everything accommodates both bicycles and pedestrians. This is where the public involvement, this is where we really had to get buy-in. This is a massive project for the city of Smyrna, largest one they've ever undertaken. So we really had to get buy-in from the public. So we had numerous public meetings. We created a model of the actual replica of the project that we carried around the back of our car to all these public meetings. It was a 3D scale model of the project. But even that, it helped, but you had to keep going a little bit further. So we created a 3D rendering of the project, and we were able to film it or render it. This is where Eric's going to come in. And so what we did is we presented this on a loop at all our public meetings. I'm going to show it real briefly, and I'm going to let Eric get into a little bit of the detail of the overall project and the design. But we did this is 7 years ago, give or take.
Yep.
Yeah. So here we're heading eastbound on Windy Hill, coming across South Cobb Drive. And if you know the area, you drop down. And if you want to go on the local access, you pull off to the right. You got access to the barbecue joint right there. Moving on, and this is one of we call it our West Bridge. our first west bridge. So you see the local express lanes going underneath, and then you got the local access above. Those are pedestrian parks, crossovers, and some other good cool features that Eric's going to mention. We kept this on a loop during the public meeting. Sorry, I stepped away from the podium. And this was huge. When the pedestrian, or excuse me, the public saw this, they could really envision it. I mean, you couldn't get, and this is exactly is being built today, with a few exceptions. So this was huge. I know that this was 7 years ago, and even technology now, we've all seen there's some even more incredible renderings like this out there. So these buildings, this is this is exactly what's out there right now, building wise. Parks on the north side. That's Atlanta Road and the railroad right there. So that was huge in getting the point across to the public so they could visualize what was happening. So that's my spiel. I'm gonna let Eric talk a little bit about how we got to where we are today.
Thank you, Chris. Few other parts, some of the parts that are also part of that video that we cut out for time today, had a first person view of the vehicle going down the through lanes. That way people understood, all right, this is how I'm going to connect here. We also follow along a vehicle on the local access roads and give them a little view of what it'll be like when they actually make the U-turns on the bridges. Excuse me. So taking the rendered model, now we got to move into the design phase. Some benefits of that rendering was we could already kind of see our typicals that we were going to build it out of. On the left here, you can see the local access and the through lanes are at the same grade, and going under the bridges, or sometimes we refer to them as tunnels, on the right. So Chris mentioned, and I'm going to call it a stepping stone project. There's a lot of different projects going on along this windy hill from 75 all the West Cobb. Many of these projects are still in the works and won't happen for years from now. So I call this a stepping stone project, but things we had to keep in mind were we don't want to create issues for those future projects. For example, our through lanes, our centerline profile, that profile needed to work with a potential grade separation at South Cobb Drive in the future. Essentially, this project has 3 parallel main lines. You got your local access, one on the north, one on the south, and you got your through lanes. We have 2 bridges that Chris has mentioned. Those bridges needed to have pedestrian areas. That was a goal of the city. What can we do to connect that north side back down? Of course, the city wants it to be aesthetically pleasing. So, we're talking planters along the major walls, planters on the bridges. They didn't want that highway feel. They don't want a flat concrete wall. So, and then obviously lighting, decorative poles. You get the idea. Some of the overall basin improvements hydraulically were also able to be incorporated into this project. And we're not going to get into that today, but there were some really good benefits that worked out for the region. Using the topography, for example, that western bridge is at a high point in the hills. So the local access lanes, particularly the southern side, needed to really match closely to existing grade. We were able to use that to our benefit and just kind of cut through the hill. You can see here how the one-way roads are going to utilize the bridges. Essentially, these bridges are acting like roundabouts at the end of a divided highway. Keep that in mind. The bridges also will keep all pedestrians and bike traffic off the through lanes. These are slower roads, 25 miles per hour. Some of the constraints Chris has already mentioned, the transmission poles, we know about that. So we were shifting to the north, a lot of total acquisitions of those properties on the north side. Some of the major other utilities, the city owns the water and the sewer out there. Included in our project was the ITS and fiber line upgrades to connect some of their signals on either end. The sewer and, the water system had to be split. And the sewer, we were mainly able to keep to the southern side with some key connections. To keep things flowing and moving very quickly, we actually broke water and sewer out and all the relocation efforts as a separate project, and we're able to bid that out early and get it under construction almost a year early. So as we were driving along, some of us might notice some of these familiar, really old Southern Belle manholes. Those look familiar. They're really big and really heavy if you've ever tried to open one. Unfortunately, along our northern edge of existing pavement, there was an AT&T duct bank. So we avoided the transmission poles, but now we got to hit this. Our center line for that through lanes was almost right on top of this. So early coordination of AT&T. In 2017, we started talking to them immediately, had a lot of meetings, worked with them on redesigning it to relocate it to the southern side. As I mentioned, we're trying to stay closer to existing grade, tie into a lot of those businesses on that side. This duct bank is a massive thing you got to avoid. The vaults are big enough for a 6-foot person to stand in and work without having to bend their head. It's a 2-foot by 2-foot concrete duct, so it's a lot of coordination and work to avoid it. You can see some of the pictures of the inside here. It is not something easy to miss. So we actually built a 3D model of it so we could coordinate it with all the other items. So overall, in the end, early coordination, as I mentioned, worked with AT&T, helped them with the redesign effort to speed that along, and gave them a super early notice to proceed. They were the first utility out of the way. And in the end, we think this probably eliminated about a year of delays. So moving on, we're getting through preliminary design, and guess what? Early cost estimates are coming in very high. As a reminder, it's a SPLOST project, so we have a strict budget. So what can we lose without cutting some of that functionality? All right, value engineering. We all had to go through this before. What can we remove? First thing was this section over here, west of South Cobb, was basically a beautification. That was an easy thing to cut out. Next, we reduced our major wall heights. We did this by some very creative through lane profile adjustments. Early on, we had kind of a constant slope of one low point, right? Now it's a lot more vertical hills. Next, the planter boxes along the top of the major walls. That was a big one. We cut those out to the joy of our structural engineers. They were very concerned about draining planter boxes right behind a structural wall. Next, the local access lanes, as we mentioned, already have bike lanes. Well, putting in a bike lane parallel to a shared use lane, that seems a little redundant, so we reduced from 10 foot down to 8 foot. The big cost item, of course, is the bridges. How do we save some money on these bridges? So, all right, let's get the beam shorter. We can get the beam shorter by adjusting our typical and our through lane. Let's narrow that down a little bit. We did have to analyze to make sure that wasn't going to restrict future opportunities in the lanes that go through this section. Don't want to tie anyone's hands. Next, reduce the overall bridge lengths, the tunnel lengths, as I will call it. That one was a little bit easier. So we had those big semicircle pedestrian areas. We're going to cut those into, we had full circles. We're going to cut them into semicircles. So in the end, this greatly reduced our haul off amount. We did have about 122,000 cubic yards of haul off. It shrunk it to the south. You can see the additional areas on the north side here. That's the old concept on the top and the newer one at the bottom. Much smaller bridges, but that extra area on the north, you know, there's opportunities there for possible business redevelopment. There's also a high chance that the city's going to combine some land and make a nice linear park. So went through the big value engineering. I should mention that actually our estimates there was that it cut about $4 million off the project. So once we got through that, we had to continue our public involvement, right? We've changed from the original picture, that original video. We did not want to spend the time to remake all that. So we came up with what you see on the screen here. These are some new renders, but they were stills. Still get the point across, and this is almost identical to what the final product was. The other thing that was a little unique that we took to these new open houses was we have 5 stages of construction on this project. We took a concept version of stage 3, which is what we sometimes call the big dig stage. It showed temporary signals, and it really drove home for all the residents and business owners that no matter what, throughout construction, they were still going to be connected. They were not going to lose the abilities they currently had, but they were going to still have access to their schools, their homes, and their businesses. Throughout design of the project, we continually had meetings with public safety officers. We met with them to ensure that, GIS would get updated during construction. Got to make sure that fire truck gets there in time. We met with the schools, with the county transportation group for the schools. We talked about bus routes, pedestrian walking routes, where the high schoolers walking, how are they crossing, even parent pickup routes. Coordination was necessary and a must here. It was very beneficial in how we plan things out. All the temporary and staging plans included temporary sidewalks. The temporary signals I talked about, they had to, on 3 sides at minimum, have crosswalks. Some of the design aspects that really drive home a lot of these features that you can see here, screen's not great. So one-way roads. Remember, pedestrians used to be crossing 5 lanes. Now they're crossing 1 low-speed lane. We put in some raised tabletop pedestrian crossings. There's RFBs at every one of these crossings on each bridge. We still got the benefit of the pedestrian areas where we can hang out, have some benches, trash cans. There are planter boxes on the bridges, separating those pedestrians from the traffic. Along the local access, some of the other connectivity with the pedestrians would be the bus stops. Our corridor had 4 bus stops. Where we're down to the 1 lane local access, we actually have pull-offs. So that bus gets entirely off the lane and traffic can keep moving. Wrapping up real quickly here, we talked about early notice to proceed for utilities, water, sewer, AT&T. Got them out of the way. We worked with contractors to have some early reviews. We did a P&A set that went out to all of them. In the end, the total right-of-way costs on this project was $21.4 million. Bids came exactly, well, not exactly, but there's no exact ever on bids. But they were right within the budget limits that we needed it to be. So the awarded bid cost was $29.6 million. Currently, the project is under construction and we're anticipating completion date in spring 2024. I will say the best laid plans still suffer from unpredictable times. The bids were opened in February 2020. We all kind of know what happened shortly after that. By the time notice to proceed was given, all the contract docs were done. Contractor was given notice to proceed in May 2020. So we are living in a different world nowadays. Huge price escalations, problems just keeping enough people working, hiring enough people to do the work. Chris is going to tag team this next section with me. We're just going to quickly jump through some current construction shots. Obviously, this was the original rendering, but you'll see we lined it up with some drone shots for you guys to just see how far the project's come along.
So real quick, so this is prior to construction, after we've already purchased the right of way. City went through themselves and cleared the entire north side as part of their efforts. Here, we're early in stage 1, working on the local access road plus a lane on the north side there. And you can see here we've got the utilities and water and sewer on the south. Continuing here, this is still stage, a little bit later in stage 1. As well as here. And one of the interesting things here, they're already building the end vent for the bridge right there. I don't know if this pointer's going to see it. Yeah, right there. They're already building that. It actually kind of gets buried during stage 1 then it'll get uncovered as we get into stage 3. So here's the end of stage 1. We got vehicles already shifted on this temporary, half permanent, half temporary paving there. We've moved vehicles on the south side, and now we're fully working on the south side. Here we're basically in stage 3 now. Vehicles are on the outside and we're starting the big dig. As you see, we're coming down. We got soil nail walls going in. Here, there's the end vents going in. Getting deeper, you can see the walls are in now, the end vents. The project's really coming along at this point. I think this is today.
Yeah,
This
this is just last week. We've already got the wall panels going in on the soldier pile tieback walls. So they're putting in the panels at the bridge locations first, then they can bring in the beams and keep working on the rest of the walls. So I mentioned this is a stepping stone project, right? Our west limits come up a steep hill to South Cobb Drive. I talked about the profile. This is actually a rendering of that future grade separation that we did for GDOT a couple of years ago. This is looking east here, and you can see in distance, real tiny at the top there, you can see our two bridges. Stepping stone project, it's just going to keep going forward, and eventually some of you in this room may even work on the one that they're working on at Windy Hill and US 41.